Now the next focus is about dispersion. Dispersion refers to the measures of how a data is spread, or it's like how spread out our data is, like till how much curriculum or how much surface we have our data spread. Typically they are statistics for which values near zero signify not spread out at all, and for the large values it signifies that it is spread out in the determined way. For instance, a very simple measure is the range, which is just difference between the largest and the smallest values. So let's get started with the new file for dispersion, and this file will be dispersion.py. Now what we'll do, we'll create it like starting with the collections. From collections, import counter, and later we specify the array which was declared over here. We can just copy paste them to have the better understanding. That is num friends with some random values. So we will be using that over here only because it is purely the statistical model. After that, we will be using the mean value. So we will be calling for mean of x, and then we'll call for the functions related to mean. So mean is nothing but sum of x divided by length of x. And then later we'll be calculating our data range. So the data range will be df function as data underscore range with a value of x, with the value represented as return max of x minus min of x. And the next thing which is important is to calculate the data range for the number of friends. So let's analyze the range. So that it will be done as data range, and the parameter now will be our array which we created, that is number of friends. Now we'll go to the command prompt. Let's clear this path and run our new code, that is python dispersion.py. So that is 75. It says max of x is 100 and minimum is 25. So my data range is nothing but 100 minus 25, which is 75. So data range is specified. Now let's get started with the DE mean, or we can say the more complex measure of dispersion is the variance. And for variance we need a separate set of mean, and that it is computed in this way, like df d underscore mean with the value of x, and now it will say x underscore bar equals mean of x. After that it will calculate the value as return x of I minus x of bar for x of I in x. Later we'll say set for the variance as df variance with a value of x, and that is n equals length of x. And let's specify the deviation. So variance is nothing but specifying the various set of deviations. So length of x is defined. The next thing is to specify the deviations. So deviations equals d underscore mean of x, and this will return a function. We'll define this function right now only. Sum of squares of deviations divided by n minus 1. Now what we'll do, we need to calculate for the variation. So we'll do sum of squares function definition right now. So we'll say def sum of squares of v with the value as return. It will be nothing but a dot product of particular vector, that is v comma v. Now let's define the dot product function. So df dot with a vector v comma w. These are the two vectors. So it will return a value as sum of v into I, v of I, or we can say V of I into W of I for V of I, V of I, V of I, comma W of I in zip V comma W, and later we'll print this variance section. So let's say print variance number of friends. So let's go to the command prompt and print this variance section. First of all, we'll clear this value. Now let's run the code again. Python central tendencies.py. Now you can see the variance section has been properly depicted with the area, how much it has been scattered. This one is completely similar, or I can say it defines the mode value. So we have got the perfect definition for the mean, median, mode, and as well as the various dispersion values. This ends with our statistical analysis of the data with respect to Python. Next chapter is purely based on probability, and after that we'll have the complete overlook about hypothesis.